Hey guys, this is Andrew at NextFab Studios again. I got the oscilloscope to work, so I just want to redo the test of the charging on the Joule Ringer. Yeah, so let's test it out. So voltage on the primary is 1.236 volts. Voltage on the secondary, which is going to be the charging circuit, is 1.19 volts. Finally got the little yellow line back, so that's awesome. So this is what I'm going to do. I'm first going to turn on the regular Joule Thief. So now, lights on. 1.23 volts from 1.37 volts. So that's how much voltage it's taking to turn the LED on. And we are pulling 22 milliamps. Okay? So that's that unit. Now I'm going to hook up the charging, the secondary battery right here. Okay? Here we go. LED gets dim, jumps up to 40 milliamps, getting drawn. The voltage goes down to 1.2. So as you can see, we dropped, about 2 thousandths of a volt from the original voltage. Check this out, the charging goes up. So I'm going to disconnect. We are at 1.2 volts. Bam. Hook it up. I just had it on again. It goes up. Energy is going into it. And here is the awesome, just amazing, I'm really amazed. Before we were getting an AC reading, and there it is. There's no more pulse on the secondary. It is a pure AC sine wave coming from a DC input. That is dope. And even on the primary, messing around with the continuity. Sorry about that, guys. Even on the primary, it looks a little bit like a nice AC sine wave even. That is really cool. Yeah, that is really cool. And it's still in the 5-volt division range, so this is a big voltage in the sine wave. So the circuit is being charged. I'm going to adjust the now I went to the other one. Went the other way by adjusting my little pod here. The pod basically adjusts the light, which also affects the charging. If I make it go a little dimmer, I can get more charging done. Yep. That is awesome. Pure sine wave AC from a DC power source. So cool. Now I'm just going to disconnect the charging, go back to regular, just a regular Joule Ringer setup. As you can see, it's all DC, all looks cool. Connect it back up, things go haywire, AC. That is awesome. I'm now just going to see when I'm going to take off the charging unit, because obviously we are charging, energy's going in. This going down a little bit. The overall efficiency, I guess I could calculate it out. Yeah, I'll take like a minute video of this. So while this is going on, I'm just going to kick back and I'm going to talk about this upcoming attraction. So Type 1 Tesla Roadshow is coming up. It's going to be amazing. They're going to be going around the entire United States, starting in Philadelphia in the fall of 2012, going across the United States. And every single place they go, they're going to set up a nice little presentation. It's going to be showing stuff like Tesla's inventions, also other practical applications, such as, I'm hoping, nice little battery, earth batteries, and talking about things like Nassim Haramein's work, Victor Schauberger's work, Wilhelm Reich's work, Walter Russell's work, all those other great people. So I'm looking forward to that, and hopefully we'll be coming to a town near you. So check it out. I'll put more information on it in another video, but I want to make sure that people definitely are understanding how awesome this is, the time we live in. More and more things are going on. And I just came off a roadshow from the Sustainable Living Roadshow, and now I get to go do this roadshow. So it's definitely a blessing for me. So I think it's been about a minute. As you can see, it's still going up slightly. It's a very slow charge. So I bet the more windings, less windings can affect it all. Yeah, I just want to show you what's going on there. So it's cool. This idea works. Oh, yeah, sorry, just forgot. I'm going to unplug it real quick, see what happens with the original voltage now that I've charged it up a little bit, and same for this. So here we go, unplugging it. Oh, and I knocked off the probe. So now we're at 1.229, 1.228, and this is dropping now. 1.17, A2, and it's slowly going down. Oh, and there's a milliamp being drawn in right now. That's not hooked up at all. The system's still hooked to the system, but it's drawing. So I'm just gonna disconnect that. No more amperage. The voltage is going way higher now. So once I disconnect it fully, we now see the system at 12.34 volts. 1.189. Just want to show that again. I connect it, current draw, disconnect it, no current draw. Yeah, so I charged it up very slightly with basically no load on the primary. So I think this is acting like a Bedini. All the Bedini does is the magnet spins, and when the magnet spins, it causes a transistor to turn off and on, and you get that nice little spike, and that's what charges the batteries. That's all the Bedini is doing. So I think that we can incorporate Joule thieves and Joule Ringers to do that without all this magnet business of spinning it. Unless we start getting into Ed's work, where you keep something magnetized for a long time and then do what I call a transpacitor, where you take a transformer and you mix it with a capacitor just by, like I said, splitting the iron toroid in half, putting an insulator in between it, and still having the primary and secondary windings. I think we should get some interesting results. So yeah, just want to show you a Joule Thief charging unit, and I'm quite pleased. Alright guys, peace.